Any question about this? Okay. If we have time, I'll come back to more. Okay. So I'm going to. So this is group. Well, maybe let me do one more. Let me do 15. Okay, number 15 on this group divergence test. Number 15. It should be page 12. So I'm going to number 15. Back to number 15. Is the nth term is, the series, the kth term is square root of k divided by natural log k to the 10th power. Right? K is from 2 to infinity. Okay. So what is the kth term? So AK is, the kth term is this one. So what I want is really to see what's the limit of this. Okay. All right. So how do we do this? Well, again, when k go to infinity, this square root of k go to infinity. When k go to infinity, natural log k also go to infinity. So infinity over infinity, this is a perfect setting for L'Hopital's rule. Okay? So this equal to limit derivative of this. I'm going to write slowly. Derivative of numerator divided by the derivative of the denominator. Okay? Alright, so what is derivative of this is the k to the 1/2, right? So this is 1/2 k to the minus 1/2. How about this one? Derivative 10 ln k to the 9 times derivative of this is 1 over k. Right? So, okay, so this will be limit k goes to infinity. I have 2 here, so 20, right? Multiply both sides by k, I have k to the 1/2 here. And this is natural log of k to the 9. Alright. Well, again, this is infinity over infinity. This is infinity, right? When k goes to this infinity over infinity. So I have to use L'Hopital's rule again. But it's good, okay, because you see the original problem I have square root of k and then natural log k to the 10th, right? 10th power. And you look, right now I have k to the 1/2, still have square root, still have this. But this power is decreasing 9. So you can imagine that next time I do it, this will become 8. And next time I do it will become 7. And keep doing it, I have this one. So, right? So eventually, how many? So let me do one more time, then I give you a general rule, okay? We can keep doing this 10 times, 9 times actually. 9 more times. You get rid of this totally. Alright? So anyway, so let's just do one more time, and then you will see a pattern of this. Okay? So I'm going to L'Hopital's rule again. So this is equal to limit k goes to infinity. So this is 1/2, right? K to the minus 1/2. 20, right? Times 9 here. Natural log of k this is 9, all right? Then that becomes 8, right? Times 1 over divided 1 over k. So this becomes limit k go to infinity. Okay, k, well, both sides like this, k1 half is 40, right? Times 9. 40 times 9. And that's k to the 1 half. But now this is natural log of k to the 8th power. See, this and this looks they are alike, but not quite. Square root of k is k to 1 half, that's right. But original problem is natural log of k to the 10. But now I only down to 8 now. So if I keep doing this, eventually I'm going to get rid of this guy. But there's a pattern of it, so we have to find out what that pattern is. Okay? So this one is very, very interesting because you are looking for pattern of this. Okay, so let's see. So let's look at this one. Okay, that's very interesting. So the first time I did it here, I have a 2 come out from here, right? So it's really, so I have a 2 come out from this derivative, from the derivative numerator. And then I have a 9 come out from, I'm sorry, I have a 10 come out from the derivative of this term, 10 come out of this. And then next time is 9. And you can imagine the next time is 8. So if I keep doing this for, you can try, keep trying, okay? Eventually it becomes this. Every time when I do L'Hopital's rule, I get 1, 2. Okay, so I'm going to do it for 9 times. Do it 9 times, so I have to 9. And now how about those numbers? This takes care of this. But how about those numbers? Well, the numbers first is 10. The first time I do it is 10. The second time I do it has a 9 here. Come out with 9. So the next time I do it, I have an 8. 7, 3, 4. All the way to 2. 5, 4, 3, 2, and then natural log of k. Okay, every time I do it, you see, every time I do the L'Hopital's rule, I bring a 1/2 down, but in the denominator I have a 10, 9, 8, so it's this like this one. So I'm going to do one more time. So, okay, bring one more 1/2 down. And this is 2 to the 9. And this is really 10 factorial. And this is just 1 over k. So this is equal to 2 to the 10 times 10 factorial. 10 factorial. 2 to the 10 times 10 factorial. Yeah. And then k, multiply both numerator and denominator by k. K to the 1/2, so square root of k. Alright, now when k go to infinity, what happens to this? Well, k go to this go to infinity. This 2 to the 10 times 10 to the times 10 factorial. This is a large number. This number is very large. But no matter how large it is a fixed number. 10 factorial is a fixed number. 2 to the 10 is also a fixed number. So this is a fixed number, but k will go to infinity. So this go to infinity. Therefore, what? Therefore, limit ak, in our case, which is limit square root k over natural log of k to 10 when k goes to infinity. This is infinity, or that means this is not 0. Infinity is not 0. Therefore, our conclusion, summation, sum of this is divergent, because the kth term does not go to 0. All right, so let me look at number here. 13, 14. This kind of thing is very, very important because in the real world, only convergent series have application. Divergent series have no application. So it's why you have to learn this, because in the real world, a series is of no use if and only it is divergent. Okay. All right. Let's look at next group of questions. Remember, this group is from 9 to 33, right? So I hope I should. Okay. So next group, 19 to 28, is integral test. It's integral test. Okay, so why don't we just pick up some of the problems here? So how about 21? Number 21. Number 21 is what? Okay, this series is k e to the minus 2k squared. Okay. And the k is from 1 to infinity. And they give us hint that we use integral test to do it. So what is integral test? Then before we do the problem, let's refresh it. What's my integral test? Here, right? If you have a book, it probably you can also see it. It's this one. This is the integral test. Integral test is on page 630, theorem 8.10, if you have the book. It says that this series is convergent if and only if the integral of the f of x dx is convergent, where f of x is defined as f of k with ak. All right. So first of all, let us identify, because they tell us hint is integral test. So certainly I have to identify f, right? So what is f? Well, normally f is very simple. You just change x. You just change k to x. You just change k to x. So f of x is x e minus 2x squared. Okay. F of x, because f of k is a sub k. So what is f of x? F of x is simply just you change k to x. So f of x is this guy. So now the question is that, is this integral is this one convergent? In other words, can we integrate this? All right, no problem. This is an improper integral, right? Go to infinity. So by definition, what is this integration? Well, this is equal to limit b equal to infinity, integral 1 to b, x e to the minus 2x squared dx.